But what happens if I don't have enough electrons? If I tried to go and make my compound using single bonds and I ran out of electrons and some of my elements still don't have octets, this is where we throw in the wrench. Then we can make double or triple bonds. So they can either look like this or like this. So I have an example here. What about CO2? Well, let's count our valence electrons. Carbon we know is 4. Oxygen is in group 16, so that's 6. 6 times 2 is 12. So this means we have 16 valence electrons for carbon dioxide. So let's try doing this the original way. Put carbon in the middle, connect each with a single bond. So we've used 4 electrons, 2 and 2. Everything still needs to complete its octet. So start with the center. We've used 4, so that means we have 12 electrons left, by the way. Start with the center, complete carbon's octet. So now we've used 4, which means we have 8. Well, 2, 4, 6. I only have 2 left. So that means this oxygen gets stuck with only having 4 electrons. But what if I did this? Put these lone pairs here and these here. And then shifted these over to here. So what I'm telling you is we're going to make double bonds. Oxygen connected to carbon, connected to oxygen. And I told you that we're moving this set to the center, so that makes another bond there. Moving this set to the center, so that makes another bond there. All right, so we've got 2, 4, 6, 8. We have 8 electrons. Carbon has completed its octet, and oxygen needs 2, 4. Each oxygen needs 4 electrons. Well, 16 minus 8 gives me 8. 8 divided by 2 is 4. Well, that solved our problem. Basically, this shows that atoms can share more than one electron with each other. In this case, one oxygen decided to share its lone pairs with carbon and carbon with oxygen, and then we shifted a lone pair over so that everybody could be happy. Because in this case, everybody wants to be happy. So now let's try some. CO2, we already did that one. What about O2? Now this one's a little tricky. So oxygen has 6 electrons, 6 times 2. That means we have 12 valence electrons we can use. So let's bond them together. So they're going to look like that. Well, that makes 2. Now I have 10 electrons to play with yet. So start filling in for their octets. 6, 8, 10. Uh-oh. As you can see, this oxygen doesn't fill its octet. Well, your brain's probably like, well, just make a double bond. Well, let's try that. Let's try and make a double bond. Let's have this oxygen give up a set of its lone pairs to share. So now it's going to look like this. Did that work? 2, 4, 6, 8, 2, 4, 6, 8. And we use 12? 2, 4, 6, 8, 10, 12. And we used 12. So that worked. So here are some more practice. If you want to pause the video and try to do these on your own and then come back for the answers when you're done, now would be the time to pause. Otherwise, if you're ready to get started, let's go ahead. Let's try OF2. First, count your valence electrons. Oxygen has 6, fluorine has 7, 7 times 2, 14, 6 plus 14 is 20. Okay, now oxygen is going to be our central atom because it is the first element. Connect each fluorine with a single bond. Fill the octets. So we've used, how many electrons have we used? 2, 4. So we have 16 electrons left. All right, so let's start filling in our octets. 2, 4, 6, 8, 10, 12, 14, 16. All right, there we go. So this is what OF2 will look like. What about C2H6? Count the valence electrons. Carbon has 4 valence electrons. 4 times 2 is 8. Hydrogen has 1. 1 times 6 is 6. 8 plus 6 is 14. So, carbon, if you see that we have 2 atoms there, our central atom is going to kind of look like this. We can put them both there to be our central atoms. Now we just have to put the hydrogens around each one of these carbons. So we have 6 hydrogens. Let's start filling these in. 1, 2, 3, 4, 5, 6. There we go. Let's see if everything has met its octet. So we got 2, 4, 6, 8. This carbon is good. 2, 4, 6, 8. This carbon is good. So let's look at hydrogens. 2 electrons here, 2 here, 2 here, 2, 2, 2. Perfect. Now, did we use the right amount of electrons? Remember, we have to use 4 and we have to use 14 and can only use 14. So 2, 4, 6, 8, 10, 12, 14. Well, looks like we're all good. So now let's try nitrogen. We know that nitrogen has 5 valence electrons and 5 times 2 is 10. All right, so your first setup for it is going to look like this. We've got 2 electrons, we need 10, so that means we have 8 left over. All right, 2, 4, 6, 8. Well, we can already see the dilemma. We don't have enough electrons around our second N for it to fill its octet. So let's have the first nitrogen give up one lone pair of electrons and turn this into a double bond. Well, did that fix the issue? Close. We're still missing 2. So what happens if we put these here as well? We're making a triple bond. So now each nitrogen has 1 set of lone pairs. Let's count. 2, 4, 6, 8, 2, 4, 6, 8. They all have 8 electrons. Now, did we only use 10? 2, 4, 6, 8, 10. Yes, we did. So this is your final Lewis dot structure for N2. What about C2H4? We have done C2H6, but now we only have 4 hydrogens instead of 6. So let's count our valence electrons. C has 4, and 4 times 2 is 8. Hydrogen has 1. 1 times 4 is 4. 8 plus 4 is 12. So let's set up our central atoms. Remember, carbon's going to look like that. Now let's connect the hydrogens. Put 2 hydrogens around each carbon so that they have the same amount. And now let's count and see how many electrons we have. 2, 4, 6, 8, 10. 10 electrons, and we still have 2 that we have to place somewhere, and both carbons need 2 more electrons each. So what if I put my 2 leftover electrons right here? Well, this carbon still doesn't have 8. So let's put this in the center. Now we've got there you go. And this is what your final Lewis dot structure looks like with no lone pairs. Let's recap. Lewis structures show the valence electrons of elements. And the valence electrons are the electrons that are in the outermost energy level. First things first, you always start with your symbol and put your dots around the symbol. 1 dot equaling 1 electron. And with compounds, you need to add up the valence electrons of each element in that compound. Then draw the first atom and connect the rest with single bonds. Then you'll use the remaining electrons to fill each of the octets with 1 bond equaling 2 electrons. And if you don't have enough electrons to fill each octet, throw in a double or triple bond. All right, that concludes the lesson for today. Have a great day.